Hi, everybody. This is Peter Cooper from the NCBI, and welcome to today's webinar. I'm going to let Cooper Park take it away and talk about the viewers and uploading data.
Awesome. Thanks, Peter. As you've already heard, and you probably already knew from registering today, the talk today is about uploading and viewing your data in genomic context with NCBI and our data viewers. So here's just a little brief overview of what we'll be covering today. First of all, I'll talk about some of the different genome browsers NCBI offers, and then discuss a little bit about why you may want to use one over another. Then I'll talk a little bit about the types of data that you can visualize in these browsers and which files you're going to need to have in order to do that. And then finally, I'll end the talk with a quick live demonstration of uploading some data into one of our browsers and talk about some of the ways you can compare this against data that's already provided by NCBI and how to share all of those results with your colleagues. So we'll kick it off by talking about which kind of tools NCBI can offer for you. The first one today is called the Sequence Viewer. Sometimes we just abbreviate that as SV. The Sequence Viewer is a web-based visualization tool that lets you investigate different gene and nucleotide records stored at NCBI. And although you can view almost any record in gene or nucleotide using the Sequence Viewer, this tool is really the best option for those of you that are interested in visualizing bacterial, viral, or archaeal sequences. Now, the Sequence Viewer itself is actually the backbone of all other NCBI genome viewers. For example, during the live demonstration today, I'll be using a different tool, which I'll be talking about in a few moments. But in reality, almost all of the features in that demonstration are really built inside Sequence Viewer. So even after this talk, if you find yourself using a different visualization tool, the odds are pretty good that you'll be comfortable with using the Sequence Viewer anyway. And similarly, if you are already coming into this with some experience using the Sequence Viewer, then moving into some of these other tools I'll talk about next should actually be pretty easy for you. The next tool is the Genome Workbench, which at its core is really like a local copy of the Sequence Viewer, which you can, by nature of being a local copy, download to your own computer and use. However, it's also a lot more than just that. It also provides several other packages that you can use to help give yourself a one-stop shop for a complete analysis of your data, as well as analyzing other sequences stored within NCBI. For example, the Workbench offers many different graphical views, including several for viewing multiple sequences at a time, like multiple sequence alignment viewers and a phylogenetic tree viewer. Or you can even view individual sequences, like exploring their feature tables and seeing all their annotations. And even just some generic views, like exploring data tables or just sequence and text. Genome Workbench also offers several analytic tools like BLAST or MAFT, so you can actually generate some of the data that you intend to visualize in Genome Workbench. And another popular feature is actually the submission pipeline that is built into the Workbench so that you can prepare and submit your sequences all from the same UI. And finally, just because I enjoy using them, I'll also point out that the Workbench also offers a phylogenetic tree building software so that you can make and visualize your phylogenetic tree all in one tool. Now, the last genome viewer we're going to talk about today is the Genome Data Viewer, which is often just abbreviated as GDV, and that's how I'll be referring to it from now on. GDV is another web-based tool similar to Sequence Viewer, but it's specifically designed to explore annotated eukaryotic sequences stored in NCBI. So while the Sequence Viewer is really the backbone of GDV, therefore you get all of the same tools and techniques to analyze sequences, GDV is also providing additional features called widgets, which can offer you the ability to do a more detailed exploration of those curated sequences that GDV is designed for. So now you have an idea of which kind of tools we actually offer to view your genomic data, but even after you've picked the right tool, you still might be a little bit confused about what kind of data you actually can visualize. So let's talk about that for a minute. This image is a cropped panel of the sequence or of the configure panel in Sequence Viewer, which you'll use to add different data in the form of tracks, which I'll talk about in a minute. But this first tab, the Tracks tab, is basically the source of where all of the NCBI provided data sets are, so that you can compare this NCBI provided data to your own data after you have it uploaded. Next to that tab, let me back up so you can see it, is the Custom Data tab, where you can add your data through several different methods. The first of which, you can actually import BLAST results and primer BLAST results directly into the viewer so that you can see where those results align to your reference sequence. And in fact, these sequence viewers also provide the ability to build those BLAST searches directly from the viewer so you can generate that data and visualize it all in one place. Of course, we have the more traditional file upload option available as well. You can use this option to import any of the many different file formats that are supported by these viewers, including things like BED files, GFFs, ASN files, and more. And I'll talk about during the demonstration how to find what other supported file formats are available. However, as many of you are probably aware, some data types just require multiple files to view, or some data files are just so massive that you need to store them on some remote repository. Files like this might be like a BAM file or a VCF file. These sequence viewers also provide the ability to upload those files by streaming them to the sequence viewer using the remote files option. So as long as these files are publicly available in like an FTP page or a GitHub page or even like a cloud bucket, you should be able to import that file into our sequence viewers without having to get it to your local machine. Now, these last three settings are a little more self-explanatory, so I'll move through them more quickly. The alignment option is reserved for uploading an alignment file from your computer. The URL option lets you upload a file from a URL. So it's kind of like the remote files, but it's more designed for those BEDs and GFF files that you just might happen to have stored online as well. And lastly, you can even just copy and paste the text from any of our accepted file formats and paste them into the sequence viewer and have it uploaded that way. And finally, before we go on to this live demonstration, I will quickly mention that there are many different types of data tracks that you can view in our genome browsers, as you could probably gather from all of the different file formats that we accept. Well, this is a list from our help documentation of the different tracks that are available, and I really encourage you to visit the link that you can see in this box here after the talk so that you can see exactly which features are provided for each track. Now, in the upcoming demo, I will be mentioning a few of these different tracks, but I just want to emphasize that between the different file formats that are available and the different types of tracks, hopefully you can appreciate that there are just a lot of different types of data that you can visualize all at once using these genome browsers. So now we're going to move on to the live demonstration for today. This demo is centered around BBS9 gene, which I'll talk a little bit about the background in a moment. And these are just some of the objectives that we're going to tackle in the live demonstration. We'll give you a pretty general introduction of the capabilities of GDV. Remember, that's the Genome Data Viewer. And the sequence viewer in general, including how to remotely add your data to GDV, how to configure NCBI provided data, and how to run primer BLAST and visualize its results. And then finally, how we can share that final view and all of those results with your colleagues. So I'm going to back out of my slides for a minute and open up my web browser. There we go. Hopefully everybody can see that okay. Okay, so the very first thing we need to do is actually get to the Genome Data Viewer. And so the easiest way to do that, honestly, is to just Google it. Works out pretty well. You see the link come up right up at the top. And so we can click it and we jump over to the Genome Data Viewer, or GDV, homepage. Now, once we get to this homepage, we'll see two little sections. The first is this phylogenetic tree looking thing, which we can use to select our organism of interest. Or if you don't see it readily available here and you don't want to dig through some of the expansion buttons, you can just use the search bar up at the top and type in your organism to see if we have it available. Right now we have about just over 12 or 1,230 assemblies that you can use in Genome Data Viewer right now, but that number is constantly increasing. Anyway, once you have your organism selected, which in my case I'll be using human, you can use this panel on the right to customize exactly what data you want Genome Data Viewer to load at the beginning. So for example, we can use this drop-down menu here to select the correct assembly we want, which I'm okay with the current assembly, so we'll just leave that as is. If you wanted and you were thinking you would be a little exploratory, you can use these chromosome buttons down here at the bottom to load in a specific chromosome. Or what I'll do today is I can just use the search bar here to type in the actual gene I'm interested in exploring, which is that BBS9 gene. So I can type it in here and then hit the search button to load in GDV. Now, I already have the page loaded over here, so I won't hit enter, but this is what the page will look like once you've hit enter on that feature search. So when you first arrive to this viewer page, you'll see several panels of data that have all been kind of stacked on top of each other. Now, each of these panels is called a track, and these are where your data actually get visualized. And when you first load your assembly, GDV is going to have a few default tracks loaded for you. But the reality is you'll probably want to change them. So to remove the unnecessary tracks from the viewer, you can use this little red X button in the top right corner and just remove the tracks. So I'm going to go ahead and delete all of these extra tracks, but I'm going to go ahead and keep this NCBI annotation release just so that I can see where the genes lie on the sequence. You can also customize the tracks that are available by going to that configure panel that I talked about in the slides. So if we click on this little configure tracks button here, we can see this page that looks almost similar to the screenshot. And here we can see the tracks that are currently active. We have the sequence track, which is represented as this little blue bar in the background here. And then we have that NCBI annotation release, which is the track I was emphasizing earlier. Now this is okay for now. I'm going to leave this page up, but so I can show you how we can also add some other data tracks. But first, let's talk about the data that I'm actually going to add today. I have some amplicon sequence read data from this patient who was diagnosed with a developmental disorder called Bardet-Biedl syndrome. And I've aligned that patient's sequence reads to this human reference genome. And you may have caught the context for this already by the gene name I looked at. But structural variations to this BBS9 gene have actually been implicated as the causal agent in this BBS diagnosis. So my plan is to use GDV to visualize the alignment of my amplicon sequence reads to this BBS9 reference sequence, and then see if there are any sort of structural variations in the patient's gene that can help confirm this diagnosis that they got. And then on top of that, I'll also try and use NCBI's dbVAR data to help determine whether any variation I do find has already been cataloged in NCBI so that I can hopefully get some more information about it. So to add my own data to the viewer, I'm going to use this configure panel and go over to the custom data tab. And then because the file I want to load in is a BAM file, I'm going to use the remote files option. Now I have that BAM file saved in a cloud bucket already online. So I'm just going to copy the link that I have for it and paste the URL here. And then just as an optional bonus, I'm going to name my track so it's easier to see. I'll just call it my data for now. And then when I click configure and then click yes to upload the external data, we'll give it a couple seconds and we see a new track added into the sequence viewer with my data imported. Now the file that I just uploaded is shown in what's called a Pileup view. This view is basically a very long histogram where the tall peaks in that histogram represent regions of the assembly that have lots of coverage from my sequencing data. And the view right now is looking a little bit condensed just because the sequences I have only seem to align to this first little chunk of the BBS9 gene and apparently some RP9 gene, and that's okay. So what I'm going to do is I'm going to use this little coordinate plane up at the top to highlight that region where my sequences are aligned. And then I'm going to use the pop-up menu to click zoom on range to zoom in on that region. Now, all track data has a legend associated with it to help you understand what you're actually looking at. And you can find these legends using the little question mark button in the right corner of the sequence viewer. We click that and then click legends. It'll open up a new tab with the help documentation of all of the possible track views. Now, this should probably even look familiar to you if you're watching the slides. This is that screenshot I have showing all of the different track views. And if we scroll down, you can see all of the details for the different tracks. So again, you can use this information to really help you understand what you're looking at in each of the tracks you add. Well, this Pileup view basically looks like it has three colors. And from the legend, I can tell you that the gray section of the view represents a solid alignment between my data and the reference sequence. The little spots of red in that gray represent mismatches in that alignment. And then this big block of black that runs across most of the sequence alignment is actually a gap between my data and the alignment. Well, it's probably not a surprise to most of you that a giant gap covering a gene and a half is probably significant in the diagnosis of a potential clinical disorder. So we're going to try and use some NCBI track data to help make sense of that finding. So again, I'm going to go back and open up that little configure panel or configure page. And this time I'm going to go down to the variation tab in the tracks panel and scroll almost all the way to the very bottom to add in this dbvar pathogenic clinical structural variants. When I click configure here, it's going to add a third track that shows all of the structural variants in dbvar that are associated with this region. And based on the legend, we know that some of these variants that are blue are based on insertions and the red ones are based on deletions. So because gaps in an alignment are generally most easily explained by deletions, I can narrow down my results and start looking through these red structural variants to see if any of them may be interesting. Now, most of these variants extend well beyond the region that I sequenced here, which makes it harder for me to know whether or not my sequenced region is actually contributing to the pathogenic interpretation that these variants are implicated in. However, at the bottom of this track, we see this little variant here that does seem to fit nicely in the deleted region. So we're going to try and investigate this one a little further. If we click on the variation itself, it'll draw these nice little tracer lines up and down the rest of my tracks to help give me a sense of what other features in the other tracks fit within the boundaries of that variant. And so it looks like we have a few exons within the BBS9 gene, which are nicely encompassed in this variant, but we can confirm whether or not those are exons by using this exon navigator in this blue bar up at the top here. So we can look here and see that the gene selected for this navigator is the BBS9 gene, which is what we want. And then we can use these little bubbles here to identify the specific exons within that gene. So when you highlight over the bubble, it will, I can't move my mouse to point it out, otherwise it'll lose the region, but you can see that it highlights a part of, or it highlights the first exon in that gene. And as we move across the other bubbles, it highlights the other exons down the gene. So by highlighting over them, we can see that exon 2, 3, and 4 happen to fall in line within the structural variant. And if we clicked on any of these bubbles, it would actually zoom in on that exon so we could get a closer look. Now, another way that we can investigate this variant is actually just by hovering over the variant and then moving down to this dbvar link here at the bottom and clicking it. And it'll open up a new panel, which is actually the dbvar page for that variant. And then we can explore all sorts of information that we want for that variant. And in fact, if we move over to the clinical assertions page, we can see the phenotype does in fact suggest that this variant is implicated in the Bardet-Biedl syndrome, which means that if we're looking at this giant alignment here, perhaps this region is the most important part of this deletion and not, for example, the loss of this RP9 gene. So that's great, and it looks like we've discovered some good clinical information that probably warrants some future investigation. But let's say we want to do some targeted sequencing of this region, whether to sequence some additional patients or maybe the family members of this patient, for example. Well, we can actually design primers to sequence in this region directly from the sequence viewer itself. And to do that, we can just use this coordinate plane again to highlight the region that we want to design primers for. So I'll just connect those two little tracer lines again. And then with the pop-up menu, we can just click this Primer Blast selection button. This will open up a new tab, and it's preset all of the settings we're interested in so that we can design primers for that region. So once I have all the settings, in case there's any settings you even want to adjust, you can change them up as necessary, and then click the Get Primers button to run Primer Blast. Now, I've already run that for the sake of time, so what instead I can do is come over to this User Data and Track Hubs widget on the right. And using this little pull-down menu, we can click the Primer Pairs track for the Primer Blast job that I ran previously, and it will just go ahead and load in that track and show us all of the top hit primers for this region. Now, unfortunately, it doesn't look like there are any primers that nicely cover the entire region, but maybe with some other investigation, we can decide that one or any set of these primers would maybe be the best option for us. So that's basically all of the features that I wanted to show off in GDV today. But I'm going to finish off with just talking about how to share this view once you've got it optimized how you want it. And there are a few different ways that you can share this view with other people. Perhaps the easiest way is to just navigate up to the top here with this share this page button. And when you click it, it'll generate a URL that you can share with your colleagues so that they can come back to this exact same view and even customize it further if they want to do some more investigations. However, I will note that this link is only good for about 90 days, so just keep that in mind as you are exploring your data set and sharing it around. You can get to a similar link by using that question mark that we use to go to the Legends help desk, or help page. But instead, we can click on this link to view button here. And when you click that, it'll generate a longer URL that you can also send, which will generate the same view, or it has an abbreviated Go USA URL here that you can send. However, the real reason I brought you over to this page is for this code right here, which allows you to embed the image into your own web browser or a web page. And there is a lot of instructions on how to do that in the sequence viewer documentation, so I won't go into it in detail here. But it is a really neat feature that you can use for any number of reasons, honestly. And then lastly, if you just need it as a nice clean PDF or an SVG file, you can use this download button on the same toolbar, navigate to the printer-friendly PDF SVG option, and there you get a list of settings that you can set to save as a PDF or SVG file. So that is it for the live demonstration. Let me navigate back to the slides for a second. And I'll just quickly touch on that there are a few other viewers besides these genome viewers today that you may find useful for your research. One of them is the multiple sequence alignment viewer, which is a great tool for, well, viewing multiple sequence alignments. And it's actually undergone many updates over the last year or so that there are many new features that should probably appeal to those of you that like working with aligned sequences regularly. And you can expect a webinar in the near future that will hopefully touch on a lot of those features for you and give you a sense of how to use them. However, there's also lots of help documentation at that link that you can use if you want to get a head start. We also do have the tree viewer if you need to investigate a phylogenetic tree. However, I'll also emphasize that if you need to, the service is also offered by the Genome Workbench. And finally, I would like to just ask everybody to take this very quick 3-question multiple choice survey regarding a new potential viewer that we're interested in developing. I promise this will be very brief. We'll only let each question run for about a minute, but I encourage you to share your thoughts with this poll. And if you'd like, please expand on that answer in the chat pod if you feel like you'd like to. So let me back out and launch this first question. We'll go ahead and take a look at those results really quick. It looks like about 57% or 43% of you do analyze eukaryotic assemblies that aren't annotated by RefSeq, whereas surprisingly, a majority of you seem like you don't. That's interesting. All right, here comes the second question. Are you interested in comparing multiple assemblies at the same time in a visualization tool? Is that something that would be helpful to you? Let's take a look again. Looks like overwhelmingly the majority of you do like to compare different assemblies, although it seems to be both same species and different species interests, which is good to know. Personally, I'm a same species guy, but it's cool to see that there's an appeal for both. All right, the final question, here it comes. If you would like to compare multiple assemblies in a viewer, what are you most interested in learning about? Again, it looks like the majority of people are interested in just about any feature they can get their hands on, and that's good to know. We like providing as many features as we can. And so with that, let me just bring this back up for you all. Thank you for answering the polls. Everybody's information is extremely valuable and very helpful to us. But more importantly, thank you all for attending the talk today at all. If you'd like to start playing around with any of these different genome browsers talked about today, you can follow the links at the top of the slide, or you can just Google the tool's name and it should come right up. We also encourage you to reach out to us on your favorite platform, be it Twitter, Facebook, LinkedIn, you name it, and share with us any feedback or suggestions you have to improve these services or even expand on the answers you provided in the poll just a minute ago. And of course, you can always email us at info@ncbi.nlm.nih.gov with any of your questions or concerns that you might have, and we'll make sure we get those addressed. But at this point, I think we can go ahead and open up the floor to some questions.
I have a question, actually, Cooper. When you showed that the view of that sort of deletion that was there, there's a way you can. Do you know how to get it so you could get so your primers bind outside that region?
I did not know how to do that, but I'm interested, definitely.
So what you can do is, just zoom into that area so that you're outside the region that you're interested in. Select it and then send that region to Primer Blast. Not just that, but get the selection outside of it. And you can also adjust
like just zoom out even further than
that, so that then you can send that Primer Blast selection, and then if you want to, you can specify in the forward and reverse boxes there, exactly where you want the primers to bind. Yeah, because that's a reasonable thing to do. So you could perhaps get some primers that would span that entire region. It might be pretty big, though. I'm not sure how large it is. It's pretty big, but that's a way where you can sort of set the primers to bind where you want them to go.
Oh, great! That's good to know.
Yeah.
Hi, my name is Sanjita Rangwala, and I am the product owner of these products that you've been showing. And I wanted to give you another tip that people don't use very much, but I think it'll work. You can actually select 2 different ranges here, and I think you can send them to Primer Blast, and maybe Cooper can try that out.
Oh wow!
Too.
I didn't know you could. I didn't know you could do that either.
What you can do is, I think if you just use Shift to highlight a region.
Yeah, that's good. Okay.
So try that, and then use Control. I think if you use move your mouse over to another region, and then use Control Shift or Control to to highlight that. Now you've selected 2 regions. Then try going to Primer Blast.
Oh, interesting. Yeah.
So it actually gives you the forward and the reverse range.
Wow, that's a great tip. I like that.
Yeah, that is very, very cool.
So you need to use Control to highlight the second region, and you can just use click and drag to highlight the first one.
Yeah, that's a great tip. I'll make sure I get a supplement in my demo script so that people have that tip logged in there.
I keep forgetting about that too. We have so many little things in here, and so you reminded me to check, and I was like, I think that works.
Okay, well, I don't see any other questions. Someone did ask about how to format a BLAST database, and Wayne answered that one, which isn't directly relevant to this particular webinar, but you can find out more about that on our help documents for BLAST. Also, someone asked about online training. Cooper, can you show your help slide again? So I just wanted to make sure everybody knows that we have one of the best places to go, I think, to keep up with to get information about, announcements about say webinars like this one would be our blog, which is the NCBI Insights blog, which is listed there on this slide, ncbiinsights.ncbi.nlm.nih.gov. You can also follow us on Twitter or Facebook or LinkedIn, and we announce whenever we have a webinar like this on there. So that's a good way to keep up with what online events we have available. Okay, well, if there are no further questions, then I think we'll go ahead and end the webinar. Thank you very much, Cooper, and thanks everybody for coming.